Hi everyone. In today's session, we shall discuss movement area method in the deflection of beams. So after this session, you will be able to know what is movement area method and the theorems included in movement area method 1 and 2 and how to solve the different load conditions by using the movement area method. So first, we shall go with what is movement area method. This moment area method is nothing but a graphical method of dealing the problems for finding the deflections in the beams subjected to bending. So this can be illustrated with the example of cumbersome and the loading is very simple. So let us recall all the deriving equations for the differential equations governing the beams. So now let us take a beam of for carrying A to B position with an angle of theta. Okay. So the radius of curvature is assumed to be small and the bending moment is m. Okay. So like this, if you consider the beam, so the deflection of the beam will be downwards and the tangents are drawn with respect to angle theta. Okay. Arc is an angle of x radius. Okay. So change in the d theta by ds is nothing but slope with respect to angle radius of curvature, that is 1 by r, that is m by ei. So d theta by ds is nothing but m by ei. So hence theta is very small. I can take it as theta as slope, that is dy by dx. So d square y by dx square can be written as m by ei. Okay, so d theta by dx is m by ei, where d theta is called as moment into dx by ei. So the relation described in the equation 1, which is the graphical interpretation of reference to the elastic plane of beam. So now referring the figure this A to B, and so the graphical, so A to B as elastic line and A1 B1 as, okay, the corresponding bending moment diagram. So now take a point O and draw the tangents AO and BO tangents are drawn from B. So both the tangents from A and B intersect at point O, and we know that d theta slope is given as m into dx by ei. So on integrating with respect to x, so d theta is equal to integral a to b m dx by ei. So from this we shall start the two theorems. First theorem is slope or theta at difference between any 2 points will be 1 by ei into area of bending moment diagram between the corresponding points. So write this. Okay. So now let us consider the deflection of point B relative to tangent A. So point B to tangent A relative to point. So that is nothing but the vertical distance between B and B dash. Okay. So the element we are considering as small and ds contributes the deflection to an amount equal to x into dq. So the deflection delta is equal to the total distance a to b x into d theta. The limits a to b are taken because we are considering between 2 points a and b on the elastic curve. So the dq can be written as m dx by ei. So delta is equal to integral a to b x m dx by ei, that is equal to a to b m dx by ei into x. Since m into dx is very small, the area of the shaded strip, okay, the area of the shaded strip and the bending moment diagram x, its distance from B. Therefore, we conclude that the right hand side of the above equation represents the first moment area with respect to B, and the total bending moment is given as A to B divided by EI. So the now deflection from the second theorem indicates the deflection of point B relative to A. So from B to A, how much it is? So 1 by EI, first moment of area with respect to point B of the total bending moment diagram. So delta A is equal to 1 by A, AX bar, and the curvature will be like this, bending moment diagram. So total curvature A to D, MDX by A minus D to B, and splitting into 2 points. So delta is equal to M integral A to D, MDX by A into X minus B to D, MDX by A into X. So these are the two theorems which are solved from moment area method. So now let us take each individual cases. So first we shall go with a cantilever beam subjected to concentrate load at free end. We all know that a cantilever beam is nothing but one end is fixed and the other end is free. So here mentioned that we are taking the cases. The free end is carrying a point load W. Okay. So like this you have taken. So first from the moment area method, let us find the problem with zero slope condition. So at least at no slope condition, we could take it as slope at A means 1 by EI, area of bending moment diagrams from A to B. This is the formula which we discussed earlier. So 1 by L, how much distance? Half, the total half, L into WL. So WL square by 2 EI, X distance. Okay. So the deflection from A to B may be obtained by second moment area method. So now in case of B, the slope is 0. So delta is equal to 1 by area into first area of moment method with respect to both A and B. So 1 by A, AY bar. Area is nothing but so half into L into B, WL. Okay, area of triangle into 2 by 3 L, perpendicular distance. Okay, WL cube by 3 I. So with respect to both the theorems, I solve the slope and deflection. Okay. So now case 2. Now we are considering a simply supported beam with a point load at the mid of the span. So we all know that in a simply supported beam, the both ends are supported by reactions A and B, let it be. And at point C, that means exactly at middle point, I am considering a point load. So at this point, the zero slope will be available. So from the first slope, A is equal to 1 by EI, area of bending moment diagram between A to C. So A to C will be a triangle. So 1 by A, half, length is half L by 2. So perpendicular the point load, so WL by 4. So that is WL square by 16 EI. So with respect to A to C is equal to central deflection. So delta C is equal to 1 by A, moment of bending moment diagram with points A and C about A. So 1 by A, same above value. So we'll get it as WL cube by 48 EI. So these are the two cases, two important cases with respect to point load. So now let us consider with UDL of simply supported beam for the entire length as W as the load per unit length. So first theorem states that the bending moment at the rate slope at the point C is equal to 1 by A midpoint area between A to C. So this looks like the triangle. So right angle triangle 2 by 3 into double L square by 2. Yeah. So like this, I would find out the slope and deflection at C and A. So these are the some important short and essay answers asked in your previous examinations. Thank you.